Hello everybody, I hope you're all doing well, and I hope you're all ready for question number 2 on our 2009 Euclid contest. Okay, so we've got question 2 here. Still have 2 parts that are light bulbs, so just final answer, and then a written question here. Alright, so A, what is the sum of the 2 numbers that satisfy this equation, x squared minus 6x minus 7 equals 0? Okay, so one thing we could do is just find the roots. It's going to be -1 and 7 will satisfy it. And you can figure this out lots of ways. I mean, you could just say, if you're really good at factoring, you can say, this will be x plus 1 times x minus 7. Or if you want to, you can use the quadratic formula. But you'll notice in the question, we don't actually care what the 2 numbers are. What is the sum of the 2 numbers? So here's a little trick that can actually help you, especially if it's a light bulb question where we just need the final answer. Suppose I had any function that was started with x squared, any quadratic that started with x squared, and it has roots a and b. If I expand this out, I get x squared minus ax minus bx plus ab. If I group those together, I'll have negative the sum of my 2 roots in the middle there. So the middle number, the coefficient of x, is negative the sum of the 2 roots, just like the last number is the product of the 2 roots. Now, of course, this formula does change a little bit if you have a constant out in front, but not by a whole lot. Okay, you can still see the a plus b and the ab. But for our particular question, we can see, so just for clarity's sake, I'm going to get rid of these c's, because we don't actually care about that right now. So we can see -6 equals negative the sum of the roots. So 6 equals the sum of the roots. Okay. So what's the sum of the roots? 6. Okay, and that's something I can visually inspect without having to find each individual root. No quadratic formula, no trying to factor things in my head. I'm done. Okay, 2b, what is the product of the 2 numbers? Same sort of thing, but now I'm going to be looking at the constant. But for this expression, I've got that dreaded 5 up in front. And this formula only works when I've got nothing up in front. But if I take a look here, divide by 5, now I'm back to where I was. So my roots have to multiply to -4. Okay. And if you want to, you can double check. I mean, you could bring the 4 over here, and what 2 numbers when I square them become 4? 2 and -2. What's their product? -4. So, I am telling the truth with these formulas, but they're nice visual shortcuts that you can look for. And they're handy. And there are similar ones when it comes to cubics. It's always the second expression. So for a cubic, it would be the coefficient of the x squared. For a quartic, it would be the coefficient of the x cubed that involves the sum. And it's always the constant term that involves the product of all the roots. And the middle terms, well, I'll let you work out that if you're interested, but they're sort of symmetric combinations of the roots being multiplied and added together and things like that. All right, 2c, determine the average of the numbers that satisfy x cubed minus 6x squared plus 5x equals 0. Okay, so here I should actually write things out. If I'm going to use, and they want the average of the numbers, if I'm going to use something like the trick I used in A to figure out the sum, because how do we find averages? We add up all the roots and we'll divide by 3. So if I want to use the trick I used in part A, I should probably explain it a little bit. Alternatively, I could just, it's not that hard. I could just factor this. I did get this right. Yep, minus 6x squared. Okay. But whatever I do, I'm going to explain it. So factor, and I'll get x squared minus 6x plus 5. Now, you don't have to explain how you factored it. 2 numbers that multiply to 5 and add to -6. These are -5 and -1. Okay. So I could just say roots are x1, or sorry, I don't know why I said x. The roots are 0, 1, and 5. So their average is 0 plus 1 plus 5. And we divide it by 3. That's 6 over 3. That's 2. Okay? This is probably the easier way for people to explain it. You'll notice I'm not writing a whole lot. This is a 4-liner. I would probably use a complete sentence for the roots of the equation are, but you don't have to do a whole lot. Now, if I wanted to be fancy and do it the same way I did A and B, I could say, well, if I've got a cubic, so here I'll explain how the cubic works. So, A, B, C are roots. When I expand this out, I'm going to get x cubed minus a plus b plus c, x squared. And then it'll be, I know I'll have minus a, b, c at the end. So it'll be minus a times minus b, so I'll get ab, and then a bc, and then a ca, and these guys are times x. So this is sort of the weirder middle expression. It's still useful. It is still useful. Okay? And so I might say by comparing to x cubed minus 5x squared, minus 6x squared plus 5x equals 0. We see sum of roots is going to just be regular 6. So the 3 roots have an average of 6 over 3. I'm just reminding them that there are 3 roots. That's why I'm dividing by the 3 here. 2. So that's another way to write it up. It's a bit more consistent with the technique I was using in A and B. But of course, you don't have to do what I did in A and B. Quadratic formula, factoring, if those are the things you're more comfortable with, you do that. Whatever gives you the faster, more accurate result is what you should be doing. Okay, that's how we maximize our results. And that's how we stay comfortable as we slowly move and get through to more difficult questions. Up next, probably a slightly more difficult question, question number 3. And I'll see you there.